Hi, I'm Aster.
I'm Wendy.
And we'll be doing the underwater fireworks demonstration by Flinn Science. Remember to wear your goggles.
The purpose of this demonstration is to teach you about synthesis reactions and show you a real-life example.
First, we're going to go over a simple synthesis reaction. This reaction is Na plus 1 charge plus Cl minus yields NaCl.
A synthesis reaction occurs when two reactants come together to form one product. Now that you have an example, let's go into the reactions that are occurring in the underwater fireworks demonstration.
These are the two reactions that occur before the synthesis reaction happens. This first one is the production of acetylene gas. This is acetylene gas, and when we place the calcium carbide into the water, it is produced. This next reaction is the production of the chlorine gas. We place the hydrochloric acid into the bleach, and it reacts to form the chlorine gas. The chlorine gas travels through the tubes into the cylinder, graduated cylinder. For this experiment, you will need calcium carbide, hydrochloric acid solution, sodium hypochlorite solution, a 250 milliliter flask, a graduated cylinder, a rubber stopper, support stand and clamp, tubing, flexible plastic, tubing, thin glass, or plastic.
Here's our setup. Make sure to do it in an operating fume hood for safety reasons.
First, place 50 milliliters of bleach into the 250 milliliter flask.
She got goggles on?
We will add 15 milliliters of hydrochloric acid into the bleach solution. Then we will quickly cap it with the rubber stopper, and then we will swirl it until bubbles form here, and then we will add our calcium carbide, and the reaction will start. Measure out 15 milliliters of the hydrochloric acid solution.
Oh!
That's so cool.
Whoa. Wow.
Now that we have seen the demonstration, we'll explain to you the reaction that occurred between the chlorine gas and the acetylene gas to produce the spark of light in the tetrachloroethane. This synthesis reaction occurs in a two-step process, where first, the acetylene gas reacts with the chlorine gas to form this molecule, and then this molecule reacts with the leftover chlorine gas to form our tetrachloroethane.
This reaction between the acetylene gas and the chlorine gas has a low enough activation energy that the room temperature in the lab has a high enough temperature for this reaction to occur spontaneously. Okay, now pause the video and try to think of a hypothesis on why the reaction creates a spark of light. In this reaction, the electrons go from a higher energy level to a lower energy level, which produces light.
The reason for this transfer of electrons from a higher energy level to a lower energy level is due to the thermodynamic tendency of the reaction to be exothermic, which means that heat is released in the reaction. An exothermic reaction is when the products formed have a lower potential energy than the reactants, and therefore they form stronger bonds. From a higher energy to a lower energy state, the energy release of the difference between the low and high states is in the form of light.
What did you think of our underwater fireworks demonstration?
It was beautiful.